In this video, I have a 5 Henry inductor across a 10-volt source, and I've got a switch. And this is diagram number 1. The question is, what is happening in this circuit? The switch is open. So what is happening in this circuit? The answer is absolutely nothing. Zero current, and on the output I've got 0 volts. Diagram number 2. The time is t equals 0. The switch is closed. The current is 0 amps. The output, however, across the inductor is now 10 volts. So we have 0 current, and on the output we have 10 volts. Diagram number 3. The time is t much greater than 0. The switch is closed. The current is at maximum. The magnetic field across the inductor is also at maximum. Now this is the graph of the current, and this is the graph of the voltage. The current is at its maximum. The formula for the current is I of t equals the max current times 1 minus e to the minus t over tau. The current has gone from 0 amps to maximum. The voltage, however, the voltage has gone from 10 volts straight down to 0. The formula for the voltage is VL of t equals the maximum current times the inductance times e to the minus t over tau times 1 over tau. And tau equals L over R, the inductance divided by the resistance. And that value equals the time it takes for the current to rise to 63.2% of the peak value. And tau also equals the time it takes for the voltage to drop down to 36.8% of its peak value. Diagram number 4. The time is t much greater than 0. That switch is open. the magnetic field collapses. And now we have zero current, and across the inductor, we have 0 volts. Now the resistance R in tau, the resistance equals any series resistance. Any series resistance along here, and that would include the internal resistance of the battery or the volt source. This brings me to the end of the video. Like, share, subscribe. Like, share, subscribe. Thanks for your attention.